Hello. In this video we're going to look at areas in similar shapes, and again we're going to talk about triangles, but it's important to remember that this property applies to any type of shape. And with that in mind, let's dive in. So here's the question. BC is parallel to DE, and we also denoted this in the diagram using these arrows. It tells us that AC is 5 units, CE is 2 units, and it tells the area of the trapezoid BCED is 4 units squared. And we want to find the area of triangle ABC. So let's call this A1. So with a little bit of work, we can demonstrate that triangle ABC is similar to triangle ADE. And let's just draw these two triangles here just to help explain a couple things in here. So there's triangle ABC. There's triangle, so this is A, B, C. This is A, D, E. And since they both contain angle A, angle A's are equal. Since BC is parallel to DE, we can then argue that angle B is equal to angle D, and since BC is parallel to DE, we can argue that angle C here is equal to angle E, and we've demonstrated that these are similar triangles. So we want to find the area for triangle ABC. So since we don't know what it is, let's give it a name. We'll call it A1. And since I know the area of the trapezoid BCED, we can say that the area of triangle ADE is A1 plus 4. We know a couple lengths here. We know this is the length of 5 and this is the length of 7. So now, the temptation might be with this problem is to try and figure out the length of sides of these triangles, maybe do some fancy work and figure out the angles, find the area, go through this long process. However, we can take advantage of a really nice property in terms of ratios of sides. And it's the following. So if two similar shapes have lengths or have length ratio L1 over L2, the areas have the ratio L1 over L2 squared. So if two similar shapes have length ratio L1 over L2, the areas have the ratio L1 over L2 squared. And this is a very beneficial property for this problem. So what I can do here is I see, for example, that I can take the ratio of A1 of triangle ABC to triangle ADE. So the ratio of their areas is going to be A1 over A1 plus 4. So now, since I have the ratios of the lengths of sides as 5 to 7, we can actually use that to calculate the area ratios, which is 5 over 7 squared. And now this problem becomes simply algebraic. So that's 25 over 49. Now we're going to multiply both sides by 49 and both sides by a plus 4, so we get 49a1 is equal to 25 times a1 plus 4. So we get 49a1, 25a1 plus 100. So now we have 49 minus 25, which is going to give me 24 A1. So A1 is equal to 100 over 24. And now we want to take a moment and we could reduce this fraction, so we could divide them both by, let's start with 4. So we're going to get 25 over 6. And if I really wanted to, because I want to think of this as an area, I'm going to actually get a decimal here. And I get A1 is approximately equal to 4.167. Alternately, I could say A1 is equal to 4 and 1/6. So the really nice thing about using the idea of similar shapes here is to avoid having to do a whole bunch of other calculations to find the area here. We know that we can calculate lengths of sides using the ratio of two known sides. We can actually take the ratio of sides squared and apply that new ratio to areas of similar shapes. I hope this video helped.